You can find trigonometry anywhere, even on the beach playing volleyball. Let's check it out. So here I've got a volleyball net set up, and it turns out that the angle between the pole and the sand here, which I'm assuming is very flat, turns out to be 91 degrees. They're afraid it might actually fall over, so we're actually going to set up this rope here to sort of stabilize it. So the pole that supports the beach volleyball net is 2.25 meters tall. So this length right here is 2.25 meters. And it makes this angle here as labeled of 91 degrees with the ground. So to stabilize the net, we have this rope that's attached to the top of the pole and extends to the ground. And that distance away is 1 75/100ths of a meter, or 1.75. Okay, great, from the base. So there we have that. And the question is, how long is the rope? So how much rope are we going to use for this piece right here? How long is the rope? And what angle does it make with the ground? So how long is this? What's the length of this side of the triangle? And also, what's this angle right here? Okay, well, let's give these some names here. Let me call this side here, I'm going to call this A. And let me call this angle, let's say, B. Okay, well, now I want to actually find this. So how am I going to do this? Well, I'm going to use the law of cosines, because you kind of want to use Pythagorean theorem. I've got two sides. I want to find the third side. The problem is it's not a right triangle. So what do? Well, we use the law of cosines. So what I say here is, since I know this angle, this is the side that I'm going to pretend is kind of like the hypotenuse in a way. Play the hypotenuse role. So a squared will equal 1.75 squared plus 2.25 squared minus 2 times that product, 1.75 times 2.25 times the cosine of that angle between, which is 91 degrees. Wow, so those are just a lot of numbers that you got to sort of crunch away. And so when you do that, you'll get this big number, and then when you take the square root, I see that, in fact, A equals 2.9, and the units here, by the way, were meters. And so I see A equals 2.9 meters. So 2.9 is the length of the rope from the top to the bottom. You see, I converted this down to something that just requires just crunching this away on a calculator, and then once you have the answer, we take the square root. And why are we taking the positive square root? There's always two square roots, positive and negative, but this is the length of rope, and that's always positive. So not a problem at all. So that's the answer to the first question, no big deal. Now I want to find the answer to the second question, what's the angle of B? Well, now I'm actually going to use the law of sines, because I've got this angle, and I know this side, and I want to find this angle, but I know that side. So law of sines tells me I get this really nice proportion, that, in fact, sine of B is to the side opposite, 2.25, as sine of this angle, which is 91 degrees, is to what we just found, which is 2.9. Right, so now I can actually solve by multiplying both sides by 2.25 to undo the division. And what I see here is, I'm going to touch their toes. Whoop, what are the ticklish? Let's see. Sine B equals 2.25 times the sine of 91 degrees divided by 2.9. That's the sine of B, but I actually want B. So how do I find B? Well, B is going to be the inverse sine function. So B is going to equal the inverse sine of 2.25 times sine of 91 degrees divided by 2.9. Isn't that the scariest thing ever? Not really, because all we have to do is plug that in on a calculator. And if we do that, we see that B is approximately equal to 51 degrees. And so this angle here is 51 degrees. The law of sines and the law of cosines are two really important laws. One allows us to find proportions between various parts of any triangle, and the other one allows us to extend the Pythagorean theorem to any triangle we could possibly imagine. They're both useful, powerful, and really pretty pieces of mathematics. Anyway, enjoy them for yourself, and I'll see you soon.